Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, it is my extreme pleasure today to introduce these three gentlemen I have here before me in the front row. I've worked with all of them since about 1996-ish, 7-ish. In fact, the gentleman in the middle here interviewed me, so it's all his fault. They've all done amazing things. Michael Cohen is a principal researcher in the Interactive Visual Media Group. He's been here for 16 years, since leaving Princeton University, where he was a faculty member. He sits at the intersection between computer graphics and computer vision, but I would say now, dare I say, you dabble in HCI?
Oh, yeah, that's right.
Which is wonderful to me. Mm-hmm. Stephen Drucker is now, I'm proud to say, working in the Vibe group as a manager of the View group, Visual User Experiences. And he also dabbles on the intersection of things, technology applications, and information visualization. And apparently he's had the privilege of kicking Bill Gates off the stage at a conference. You're going to have to ask him about that later. And Andrew Glasner is no longer with us, but was in MSR for a long time and also in product. I remember you moved to product and then came back, right? You're one of those few who's tried that. Also well-known in the computer graphics community, and originator and editor of Graphics Gems, a series, and an introduction to ray tracing. His most recent book is on processing, and he's done all kinds of things, including interactive fiction, writing and directing, 3D. I remember Wild Tangent was in his history somehow, right?
Well, something related to
Yeah, we worked with you on that. So fascinating background, lots of books. Definitely hang around and listen to these guys present what they've been doing with girls, programming and processing.
Great. Thanks a lot, Mary. So we're going to do this a little informally. This all started primarily because we had girls who have known each other essentially since they were born and are now classmates after many, many years. And summer came along and thought it'd be an opportunity to kind of try to infect them with things that we think about a lot. And this was our attempt at doing this. So mostly we're just going to talk about the experience of doing this one-week class this past summer. I should preface it to say this is something that was completely new for us to do. And we'll try to share with you a few things that we learned, and in particular, if it's something that you're interested in doing yourselves for a group of kids, we'd be happy afterwards to talk to you about at more length and give you everything that we did and help you set something like that up. So let's see. So first, what were our goals in doing this? Clearly, at least the two of us wanted to introduce programming to these girls. But importantly, this had to be fun. It was in the summer. They had just finished their school year. Of course, we wanted to make this empowering for them. And a big goal also was to create tangible artifacts. We didn't want them to just leave with some memory of some programs, but be able to carry something with them. And it's always important in any of these little classes. You can show something to your parents at the end. We had no illusions that they were going to walk out after a week and be self-sufficient programmers. But at the same time, we really also wanted to avoid scaring them away. We wanted them to walk out and hopefully think this was a fun thing, and then maybe as it came up later in their coursework or in their lives, they would have some sense of what was going on.
So part of this, by the way, was because while we wanted them to learn programming, this was not necessarily an express wish that they had. They would put up with their fathers kind of talking about how cool it is, but not so much their own great desire to do this.
Yeah, so I should say, we tried another thing earlier on, which was to do a robotics class. This one took place, this one was at our house. We had another one at Steve's house. That was reasonably successful, and it was boys and girls, and that's another reason why you see the word art here. What we did is we had a week. We did 9 o'clock in the morning till 3 in the afternoon. There were 7 girls, all having just finished 7th grade, going on to 8th grade, and they all knew each other. They're at Lakeside School, if you know Lakeside School, and they were all in, I think all but one in the advanced math class there, and importantly, 2 of them were our daughters. So this is not a sort of a generic group of kids that just came together and didn't know each other. So there's a lot of good dynamic going into it. Yeah? That's a really good question, because I think if we had put out a call, we would have got a lot of competition. So we kind of handpicked them.
But we picked them sort of based on ones that got along, not ones that were, oh my God, they would be great at this. It was more, is it a good group of people that get along
and also not ones where
prima donnas or
well, the parents go, oh, this will get you ahead or something. These were, So we handpicked them, I guess, is the way to go. It wasn't hard. I think we asked maybe one additional one, and everybody said, oh yeah, that'll be great. Let's do it.
And actually, it was a little tricky because there were a lot others that would have liked to do this, but we didn't really want to have more than 7. In fact, I think we wanted to have 6 originally.
Started out with sort of an idea of 6 and ended up with 7. So what do we do? This was it was posed as a computer art camp as opposed to a programming camp. 2 keywords, art. So we geared this so that all the projects would be visual and essentially have artifacts that they could create. And clearly it had to also be a camp, which meant a lot of downtime, a lot of time for them to just run around. We had imagined, actually, we have a park not too far, that they would just go out and run around and do a lot of other things. As we'll talk about, we didn't end up having a lot of downtime, and that was not our fault. It really was their fault, because it was very hard to get them to stop. Anyway, so we also, as we were getting into this, trying to figure out what to do, we talked to Lynn Langett, and she works with another guy named Llewellyn Falco, and they have been developing a program. They're down in California, and they actually came up here, which was great, and gave us a whole sort of mini class as if we were teaching. They use something called Small Basic, which we can talk about a little bit. But what we really got from them, a big thing, was this idea of always having them program in pairs. So in the beginning, so each day we would have them sit in pairs, and since there were 7, there was sometimes a group of 3, and one person would be sitting there at the keyboard typing, the other person would be kind of responsible for telling them what to type, and it just made for a very nice interaction.
And we alternated that a little bit, although they were fine with just sort of mixing it up themselves. So.
Yeah, and anyway, we let them sort of take the lead on a lot. But the other thing is, in the afternoons, so they would create a program that would do something they could do something with, and then once they got it going, then they would spread out. They all had their own laptop. They'd spread out, and they'd all make their own art. So it wasn't it was a sort of team effort to do the programming aspect, but then an individual effort to create these artifacts. And as you can see, basically everyone had a laptop. It had to fit around our dining room table, and that's pretty much the restriction of 7. Maybe we could have, actually there was another chair here that wasn't there at the moment. They all had memory sticks so they could share code that way. That was the easy thing, although in fact they didn't do a whole lot of that because they were more or less staying kind of in lockstep until, we'll talk about what happened sort of towards the end. We had a projector just projecting up onto a flip chart, another flip chart. Didn't use the flip chart that much, a little bit, but often Steve and I are standing down here and typing, and they could see what we were typing and could ask questions like that. Then we had a nice color printer, which we used mostly on the last day. We'll talk about that. So, made a bunch of other choices. One was to use processing, and this is probably one of the sort of the touchiest and most important choices one makes. And we'll talk about why we did that. And also Andrew is here, and I'll introduce him more at the end. But he just finished this book, and I'll talk more about that in a little while. But basically, this is a language that was made essentially for artists. There was a bunch of pros and cons. I don't know if you have some.
Yeah. Again, this was one of the tougher decisions that we made because it's got a terrible IDE. It really is hard to debug and it's hard to use. But if you look out on the net, and it'll show you a whole bunch of examples, a lot of artists are using this for installations, for their own artwork, for visualizations, and it was sort of that promise of being able to create exciting things that made us go in this direction. It was also pretty easy for us to learn because it's really based on Java or C#. So for us it was trivial, and Michael and I spent quite a while beforehand going over how do we teach this, and that was actually a really interesting experience because obviously we've been programming for years and years, and we wanted to make something interesting but that we could introduce slowly, and then we kept saying, oh, but that's a hard math thing. Oh, but this is, that's really complicated. So how do we structure this? And you'll see this more. But it was really helpful that we were facile in the language so that we could teach it well.
Yeah, and like I say, we had a lot of fun. This was coming up, we spent a lot of time just sending little programs back and forth, saying, oh, it's so cool. How can we get them to, how can we simplify the concept down to do that?
And we did look, there's a lot of work on teaching girls programming. There's some work called Alice, which is at Carnegie Mellon. And in fact, there's even a Alice for telling stories, which they've used for teaching girls. I think Mary actually helped advise that student that did it. But and then there was Small Basic, which is nice from Microsoft. But again, we didn't see the compelling artifacts right away, and that's kind of why we went this direction.
Mm-hmm. So one problem was that we really wanted them, because it didn't have this nice programming interface, we didn't want to bog them down with syntax. And so essentially Steve and I were the auto debuggers, right? We were the sort of instant, you just push one of our buttons and we debug their program for them.
It's not working.
And it's, syntax is a terrible thing and it's too bad, and there's a lot of tools that help you in other languages but not in processing. So often, somebody would just go, it's not working, and we'd be presented with something that looks like that. We'd say, well, sort of kind of subtly hint that it's nice to indent things and to do a little bit. So we'd say, okay, well, how about if we were to format it? And then we'd say, but actually, this line is probably supposed to go inside the curly brackets. Oh, okay, I just added that line. So, so we move it up, and sure enough, things worked. We never forced them to actually figure that out because, there were 6 other girls around the table where it was working, or, maybe 5 were working and 2 are going like, help, 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 help. And so we would just go up and essentially fix it. And we'll talk a little bit later about, the pros and cons of doing that, but I think in the end it was a good idea. So the plan was to basically spend a couple hours in the morning writing some code, and then have a nice long lunch, and then come back after lunch and use the program that they had made, or maybe do some modifications to that program. And we crafted basically the 5 days something like this, where the first day and first 2 hours they're supposed to write a complete paint program. The second day they're supposed to learn all about ball dynamics and be able to write a full simulator. A complete word processor they were going to write on Wednesday, and a complete image processing suite on Thursday. And
you think we're joking?
I can report right now, and you will confirm, they in fact did all 4 of those projects before lunch each of those days. So I think what we were going to do next is talk about the paint program a little bit, and this is a couple of the paintings that came out of that day's work from a couple of the girls, and figured the easiest way to do it is that we're going to get you guys to write a paint program while we're here. And let's hope that this works.
Yes, exactly. And we'll actually sort of do it the way we did it in class, which was sort of Michael would be talking, and then I do it, and the other day we'd switch, and Michael would be...
Every processing program has one function that starts out, it's called setup. And this is a fully functional program. So I get them to, they actually typed this in and say, well, every time we type something, let's run it. And sure enough, that's the program, what it does. So you guys have any ideas how to make it more interesting?
No. Tell us how to draw. ellipse colored square.
Well, the first,
I saw ellipse
yeah, see, you guys are so far advanced. They were going like, ooh, that's an ugly gray. Can't we change that color? So we said, all right, let's try, how about 10? See what that does. And of course, we can run it. And look, oh, it's a darker color. And going, oh, that's no fun. I wanted mine to be purple. So, okay, how about, I don't know, 100, 150, 20, and 200. And sure enough, hey, look, purple background. So why did that happen? What are these numbers? And they're smart enough, some of them have thought about it, and I've certainly taken a magnifying glass up and showed them how, color makes, because I do computer graphics. But anyway, let's go back to just making it 10.
We actually challenged them at that point. Just, can anybody make yellow?
Oh, yeah.
And,
can anybody make yellow? So they just were going crazy, and they're running around, oh, that's a cool color. And they would run over to the other side of the table to see what color they had made and come back. And, instantly they're doing this. So that was it. Now, every program has one other function called draw. And the nice thing is setup runs when you start the program. Draw will run every time every frame time. Okay? And so there's one function called ellipse, and you put 4 numbers in there. Okay. And let's just try running that and see what it does. And sure enough, there's it draws a little ball. Sort of explain what an ellipse is a little bit. I think you've heard that. So what do we need to do to make a paint program? I mean, that's interesting, but...
Yes.
Okay. So it should follow the mouse. So let's make it follow the mouse. Let's try running that. All right. So does this look like a paint program yet? Pretty much. So what should we do next? Any ideas?
Change the brush size.
Change the brush size? Okay. So where do you think sizes are in here? So let's change it to 50, 50, let's say. Oops. It's probably not what you meant, right? So what else?
Be able to start and stop.
Sorry?
Be able to start and stop.
Yeah, it's a sort of drag wherever he goes. First of all, first thing they complained about was this edge that was on there, right? So there's a magic function called no stroke. And that'll run. And then, as Matt was saying, we should figure out a way to get it to do that. So this is where you can say there's a thing called mouse pressed. And this is where you learn a little format. And sure enough, you can do that. And we're getting there. We almost have a paint program already, right?
A user interface.
You need a user interface. Okay, so what do you want to do with your user interface?
Brush palette, color palette, size palette.
Yeah, all right, well, let's do all that. So we didn't want to get into building user interfaces, and this is, as you know, there's no UI toolkit with this language, and that's going to be a pain. But we actually did that at the very end, and I'll talk about maybe that on Friday. So why don't we just bring in some code that is down below now. All right. And let's run this. And now, a couple of things. One is we introduced variables, obviously. Maybe we can go back and let's go look at the code for a second.
Yep.
So somewhere up in here, we introduced some variables. It has, right? So there's a thing called fill for changing the color. We set the RGB, and there's actually an alpha for setting alpha. This, I'm not sure why we have the stroke one in here. And then we use this thing, if mouse, actually, can you go down to the key pressed?
Yeah.
Essentially, our user interface was this. Go up a little bit. It says this key pressed. So this was our size. We used these keys to make the size bigger and smaller. Similarly for R, we used R in capital R, or B in capital B, and G in capital G. So you could just put whatever you wanted in there to make different things. You could change it. You could be pressing a key while you're doing it. You can be changing the color while you're doing it. And that was about another, I don't know. I'd say by And we didn't just give them everything exactly what to type. We talked about each thing. We said, what would you want to do? Oh, we want to be able to change the color. Oh, we want to be able to change the size. And kind of handed them alpha. I don't think they came up with that. But pretty much by then, they were just off. In fact, at every step, the key was that they just suddenly they have this incredible extra power with this variable that they could change, and they would just sit there and start painting, and again, just constantly running around to see what they were doing. And this pairing was a really nice thing too, because a pair would say, "Oh, let's try this," or "Let's try that," or these little teams, and they'd be building these
and then
programs up.
One team would do something and they call the other one over and, oh, that's cool, and then they go back and say, oh, we could do something like that or something different, and give each other ideas. There was a lot of ideas within the pairs and also between the pairs.
So another thing here is there's a function called save, which will just save the screen into a PNG or a JPEG file, or PDF even, if you would like it to. And this is just a little thing, my daughter's name is Lena, was to make the file always be unique. So whenever they hit tab, it would just generate a unique file name starting with Lena, and would just write out that thing. So again, you could be painting, just save it, and painting and save it to do different things.
And the key thing here was that while we gave them some of this hand-holding at the beginning, they really did start sort of improvising on these things. They'd get the concept of the variables pretty quickly, and then, oh, this is how we can change the size smaller, and this is how we can do the other things.
Mm-hmm. Okay. Yeah.
General language question. So, did you explain into the language up front, or was it all sort of just-in-time explanation? And did you do like minimal explanations, or did you try and generalize? Like an if statement takes a Boolean expression?
Yeah, this was something we toyed with a lot, and it would seem pretty clear in, especially when talking about it, they weren't interested in understanding the syntax at first, except if it gave them benefit. So when we added the if statement for the mouse pressed, then, now I understand it, and they really got it. And the same thing, we did this sort of variables, and I know Michael's thinking about, okay, letter envelope boxes. So we sort of kind of did that, and they just got it. And so some of the things we were really impressed that they just got right away. Yeah. And again, we didn't do, we were thinking beforehand that we were going to do recursive functions and all these other things.
So I probably should have showed you before we close it. There's another function there that's called random, which we made liberal use of. And in this, for example, this is in the afternoon. So they wrote the basic paint program, and then in the afternoon,
I'll just open that again. So keep on going.
So you scroll down.
Yeah, I need to.
So in the afternoon, they wrote fancy brushes, and they each did these on their own. And so essentially what they did is, I'd like to do something like this. Could I do this? And then we'd work sort of one-on-one with them to make a fancy brush. So, So some of them are basically would. Want
to see that one or another one?
Remember. Anyway, they would sort of randomly perturb the brush and randomly perturb the color, and then just sort of have this kind of airbrushy thing. And they each did very different ones. Yeah. So that's one of the brushes. And again, just by hitting a number on the keypad, you switch which brush you're using. Okay.
And I don't know if any of you have encountered kid pics, but a lot of our kids kind of grew up doing kid pics, and they felt sort of, wow, I'm doing my own kid pics. And they kept on adding new kinds of brushes, and they didn't do sound effects for erasing things, but it was part of that.
So here's a couple of the pictures that they generated in this process. This one was from that brush that you just saw. This was actually the very simple brush, but they literally would add sort of random the color, and they'd be changing the size as they're painting and changing color.
That was kind of fun because actually it took two people
on the keys. It was really fun to see. And at this point, I just want to show you a very short little video, which I think I queued up already. So this is about literally 3 hours into their life of programming. So I think this happened just shortly after lunch. They were back and starting to modify some things. It just kind of gives you a sense of what's going on.
Yeah. Okay, so we put S, so you would change the size of S, like a perfect triangle.
And then instead of this ellipse
It's a
thingy,
rect.
you just do
Mouse.
That is so simple. Okay, I need to
turn the fancy brush into a triangular fancy
So
brush.
we can do the exact same thing inside.
You just do F, mouse plus S.
Yeah. So you get the idea. One of them has figured something out, and the other one's starting to sort of talk. We spent, I expected us to be up there, kind of constantly running around. By the time, literally a couple hours into this entire process, we were, two of us were sitting in the kitchen, going like,
Okay, now what?
And periodically, someone would like look over and go, something's not working. And you'd go over and, change it, add a semicolon. I mean, that became our life, was just adding semicolons. So it was really fun. Okay, so the second day, and we're not going to take quite as long on each day, but we did ball dynamics. But I think what we'll do is we'll try to at least get started on this one as well, and we'll do the same thing. Okay, so here's our basic. So what's this program going to do? Well, let's run it and find out. So it looks just like the last one, right? But now, instead of having the mouse move the ball around, mouse move the brush around, now we'll call it a ball. So what do you have to do to make ball dynamics, right? What did you learn in Physics 101? What do we need? Force. What does force cause? Movement, which is, yeah, all right. So let's add a couple of things. We'll have the position, and, I don't know, sure.
Yes. Speed. Sure.
Sure, how about a couple more?
What do I call them?
Vx for velocity, of course. And Vy for, yeah, sure.
Fine.
Why don't we add some acceleration while we're at it, since we're typing stuff in. We'll just set those to 0 for now. All right.
Okay.
Where are those going to go? Well, that's the position, right? And
actually, we'd have them run like this, and it was like, oh, it's not moving at all.
yeah.
Oh,
All right.
so what should we do?
So what should we do? So we're going to have, go ahead, let's just do it. Sub x equals x plus Vx, and y equals y plus Vy. What's going to happen?
And that took a little while for them to sort of...
So we really started, so what's going to happen now? And they're all going, gee, I don't know. So a lot of times we'd give them something like this, or they would say, we have to get it to move, but we'd probably give them that, and then really wait until they guessed what's going to happen. So let's try it. What's going to happen?
Oops.
You think? Yep, it's gone. All right. So let's go back. Why don't we up the velocity a little bit, just to make it fun. All right. And
Just run it again. Again, we just kind of run it all the
sure.
time.
Faster. So now what do we got to do?
Bounce.
So how are you going to do that? Okay. So anyway, so we said, if x is greater than, and we have this number up here. Remember the size of the screen.
And
So what do we need to do? Anybody have an idea?
Negate the velocity.
Negate the velocity. Very good. This one
That was not the first guess of people.
That was not the first guess.
A lot of people would say, well, let's set it back to something. And it would, that wasn't quite right. And then someone said, well, you could stop it.
Yeah, let's try running that. Let's see what that does. Ooh, worked. Uh-oh, went off the bottom. So we go on, to do the bottom, the other side. But let's add, why don't we add acceleration right now? Let's just set AY to be 1. What's going to happen now?
Nothing.
Oh, that's right. So we added these, yeah.
Oh,
What happened there?
well, let's just do this one thing. If y is greater than 600, y equals
probably add
minus
make-
5.
We should make AY a little smaller, too.
Yeah,
Okay.
and I'll go
Amazing,
off the other way.
isn't it? All right. So before long, we've got, literally, this is, again, they've got this, and now what can we do? Let's try running one of these.
Oops.
So let's try this one.
This bounce? Okay.
So this one took a little hand holding, but not too much. and said if you can make one ball, you can make a whole bunch of them. And then, question, how are we going to make art out of this? Anybody got an idea? Anybody an idea how to make this into some cool art thing? One line change. Well, yeah, you could just keep hitting print. But what's going to happen if we comment out this line? Let's try it. Yeah. All right. So you can start to see where they'll start going wild. Now, let's be able to change this. Let's be able to change that. And again, oh yeah. So then in the afternoon, we said, what do you want to do now? Should we extend it, make it so you can change the colors, make it so you can change the forces? And they were going, ooh, let's make a Pong game. Like, yeah, sure, why not?
They do a Pong.
Yeah.
I don't. Maybe they'd seen it in Flash games. I don't know.
So or let's make a game. Maybe they said, let's make a game. We can shoot or something like that. So in fact, they wrote this thing, and if Steve were any better playing it, we could. And you'll notice this was too easy after a while. So he said, all right, how about every time we did, keeping score up here, every time it hits an interval of 5, the paddle gets a little bit smaller. And then to make it a little more difficult, one thing you'll notice, it's adding a little random perturbation actually to the velocity in here. So it's getting pretty good at it.
Yeah, right. Actually, they ended up playing this game.
And it's changing color and Anyway, so they were just love the fact that they made a game. So all of this really is not much difference between a paint program and a Pong game.
And by the way, the Pong game was not something that we planned out beforehand.
No.
So while they were eating lunch, Michael and I were chatting and said, well, they wanted to make a game. They said that before they broke for lunch. Can we do this? So very quickly we just did it. And then we did the enhancements with them afterwards. And again, it was nice to have the structure for them to go.
Mm-hmm. So that was day 2. So again, by the first day they had written a complete paint program. Second day they had written a whole simulator and ball dynamics. These are some of the art that came out of that. Again, you can see by setting different kinds of parameters and changing the opacity in this one or whatever. And again, as things were going on, they would keep hitting this little tab and could record these images. Third day was fun. It was a little less programming. We decided to write a word processor, and we did, in fact, spend a little time in the morning to get them to be able to literally type and hit spaces and then to do backspace, which was a trick, and to get it to wrap down to the next line using fonts. And then, so they got that, and then we said, why don't we make our own font? And you guys could just make it. And we sort of had this idea that they would go out and maybe find some sticks or trees or some way to do it, but it turned out to be kind of a rainy,
yucky day.
I think, what are we going to do? Maybe we could get some silverware out or whatever. And anyway, they decided to use what they had and just gave them a camera. And they spent probably 2 hours making this font because it wasn't right, and they had to run back up, and they were, trying to do this. But anyway, eventually they constructed this font.
I think in one picture, someone's shirt was a little bit up, and it's like, oh no, we got to take that picture out. They went down, they went back down and take that picture again. And
so it was in some ways a quieter day on the programming front, but I think they got the idea of the complexities of being able to hit backspace and being able to erase something and keep track of where the cursor was, and we got that through. By the end of the day, they had pretty much worn themselves out and didn't end up writing a whole lot. I sort of imagine these little poems as these things, but we didn't get any wonderful poetry.
And just the lighting didn't quite work out nicely, so it's kind of hard.
A little hard to read. I don't know if you can even read this. This is a couple of the girls, Anna Cullen and Lena Yishko, and my daughter, are awesome. It says. Anyway, so that was the third day, and on the fourth day, we decided to do image processing. There was a lot of really wonderful, it makes it very easy to bring in an image and to create an image. And just to show you some of the artifacts they created, this is, we asked them all to do self-portraits. So the first thing they did is took the camera and took pictures of each other so they could bring in a picture of themselves and use that as the backdrop. And then on this one, all it is literally randomly picking a pixel and moving it either up one or to the left one or down one or to the right one. just so using random pick a pixel and move it 1 pixel in some direction. And then you just let it run. It's really fun. You just kind of starts out there, and as it goes, it just starts fuzzling out. Right? Or we wrote another one called Melt that just kind of takes the pixels and they start kind of dripping down the screen. This one is very similar, except instead of a particular pixel, it takes a little square and does the same thing. Just moves it, perturbs it randomly about. We did a couple of other just real simple things like doing a negative. Sort of talked about what the negative of color was. If we had RGB, what is the negative of that? We did a solarization thing too, which is kind of just making sort of half of the thing negative. We had a lot of fun with that. And then this one was a little different. We ended up combining the paint program with sort of an image program. So this was kind of scratch painting in a way. Essentially what you did is you move the mouse around the screen and it picked up the color from the underlying image and put a rectangle of that color.
And if you were moving quickly, it would make it bigger.
If you made the quicker you were moving it, the bigger the square it would make. And so you could really do a lot of fun things with that. So they had a lot of fun with this sequence, actually making things. It turned out to be a very relatively small amount of programming. I did a lot of help in providing this last one. They created, anyway, it was just a really nice thing. The last day we did a little bit of user interface. We went back to the paint program and actually had them draw little red, green, and blue bars that you could slide the mouse over to pick, and then you had a little square that showed the color. And that was quite interesting, trying to work with them. They were very good at coming up with how to do it. But kind of could see after the 4 days of sort of really powerful stuff happening, creating user interfaces, really kind of got
I also
tedious.
had to miss this last day because I was leaving the next day for Brazil, so Michael had to take this one on his own.
Anyway, so we didn't do that for very long, but we actually built that little 3 sliders. But most of the rest of the day we spent printing out the results they made, and I'd gotten a bunch of mats that they could sort of frame some of them, and we just pulled all the stuff off the walls in our dining room and started gluing things all over the walls, and they really had a great time. One of them said, "Oh, this wall's going to have this theme, and this wall's going to have that theme," and each couple of girls were working on this wall and that wall, so that when their parents came to pick them up in the afternoon, they could see what we had done over the week, and then rip them off the walls to take home. So, how do we do on our goals? 2 of these goals, I think we did quite well. 2 of the goals were somewhat in conflict, right? We wanted to be empowering, but we really didn't expect to make them self-sufficient programmers, which is really kind of an empowering thing. So it's hard to say, and I still struggle with this a little bit. Should we have gone slower and really, taught them some syntax or sort of what was really happening, what a semicolon really kind of meant, and curly brackets, and what declaring variables, and I think I'm still glad we did it this way, but clearly none of them could walk out of there and sit down and just.
And it was a camp, so there wasn't. I think some of this needed to sort of percolate in their heads, maybe in a homework-like assignment where they had to now generate it on their own without watching or whatever. But again, that really wasn't the goal. The goal was, I did this once. It wasn't hard. I could do this again. And in fact. There are various times in the class, in their school, where they might have to do some sort of repetitive task. And now Renata's actually said, we could do a program for this. I said, yeah, we could, if you had more time.
Yeah, they had a homework assignment, which was, what's the 1000th term in this series? Right, so they're doing a mathematical series, and the question is, what's the 1000th term in it? And they're like, ooh.
Yeah.
So, yeah.
Did any of them take the laptop home any of the nights and actually continue with what they had done during the day?
No, I didn't hear about that. I know a lot of them took things home and showed their parents what they were doing. I didn't really get reports of them doing a lot of modification of it later on.
Even after the class?
Yeah.
Like weeks after?
Yeah, very little.
Yeah.
Mm-hmm.
Do these girls have like Facebook or anything? Did these artifacts make it outside to their social contacts?
I know that my daughter didn't start doing Facebook until actually the end of this summer. It was just exactly the timing, and I don't know about the other ones. But
Yes.
I think it's interesting what you just said, and I'm wondering how you're going to measure the impact, really, because I think that's important. But that one of the kids said, "Oh, we could create a program to solve this," because that is a huge leap. That they're now seeing how computer programming
can help them in
design is relevant to their lives, because that's one of the huge issues with girls and technology.
Yeah. So I'd say the jury is really out on, we did this as a one-off. We're not really planning to do an evaluation. We'll see it in our own girls somewhat. We are planning to go to the 8th grade math teacher and talk to him about this and see if he wants to do something similar in his class this year.
Yep.
He's been teaching at Lakeside forever, and he said they used to do some programming, but now there's so many programs that are already usable. You didn't have to. You sort of had to many years ago. So maybe we'll get that introduced back in. So one goal for sure we were successful at, and that was it was super fun. I mean, I can't tell you the number of times when they would just leave it, that is just so cool, and everybody would rush around. And those moments, at least, for me, were just phenomenally fun.
And we just showed one of those little videos, but there were a lot of pictures. He didn't take the video camera out enough, but there were so many of these things. Just, I wish we had captured that.
Yeah, yeah. And one of the girls really was clearly just kind of got it at some point and was running around and just, helping the other ones out, and it really was nice. So with that, I want to introduce Andrew. Andrew, you got the introduction from Mary, and he's written this wonderful book. And I encouraged him to actually bring a box of these books with him. So if you're interested in one of these books, talk to him after, and I'm sure he can make some arrangements for you to purchase one. But anyway, I want to just let Andrew talk for a couple minutes about his book and his passion for processing.
Thanks, Michael. Yes, if you want to buy books, I know a guy. We can make a deal. Michael actually asked me to do two things. And we've switched. Can we switch back to the previous laptop? So I wanted to do two things. One was to talk about what other people have done with processing and show you why I think it's an interesting language. And then I'll talk a little bit about what I learned writing this book and then developing a course based on it. So the way I got into processing was a couple of years ago. I was giving a talk at SIGGRAPH on the basics of computer graphics, which I've done for like 20 years. And it's always been on 3D graphics. And I thought, I should do something on 2D. And I sort of made a list of the usual suspects, and I looked at Flash and Alice and Squeak and Squonk and Scratch and all the different languages. And, I thought, okay, they're all good 2D languages, and I'll just pick one. And then I ran across the website of an artist, and his website blew me away. Actually, let's just jump right to it. His name is Jared Tarbell. Do we have to switch to the... Here we are. Okay, so his name is Jared Tarbell, and he's got a number of websites. This is complexification.net. And let's go to here. And I just want to show you some of these programs he's written in processing. And when I saw these, I thought, wow, okay, wait, there's something going on here. This is an actual running program. Let's go ahead and run it. I'll launch the medium-sized applet. And now it's running. It's driving itself off of random numbers. But I looked at this and I said, holy smokes, there is something going on here. This is not just a little random toy applet thing. Wow. And I wanted to learn processing. So in the hands of somebody who really knows what he's doing, processing can do amazing stuff. Let me just show you a couple of other pieces from Jared Tarbell, who I have never met, by the way, but I have exchanged email with, and he's a very nice guy. And all of these are on the web. I'm running live web pages here. And one thing you may notice is in the bottom, there's a source code link. When you write an applet in processing, It's a one-click menu choice to say export. You export it, it makes an applet, it makes a web page, it makes all sorts of stuff associated with the web page so that the applet will run. It makes a link back to processing if you haven't downloaded it, and it gives you a link to the source code. The idea is that, heck, the code should be there. You don't have to. Obviously, you can edit that out. But part of the aesthetics of the community is we share our code. And it's wonderful, of course, because that's how you learn what other people are doing. This is a really interesting applet. What he's got is a number of moving circles that they're hidden. You can't see them. What he's drawing is the places where the circles overlap. And so you get a nice little bright white dot where the circles cross on each other. It's just gorgeous. If the room was a little darker, I think it would look even prettier. He has a version of this where he traces the curves, and that's what this applet does. Here, this is the very same thing, only instead of clearing the screen each time, it's remembering. You know, it's just accumulating those intersection points. And, you know, by golly, they start to really look interesting. He's also invented a really beautiful line drawing technique, which he calls a sand painter, which he's using here, which I just fell in love with, and I've used a few times with his permission. And initially, it was mysterious to me as to how it worked. I opened up his code, figured out what he was doing, changed it to make it the way I liked it, and now I use it as just another primitive. Let me show you a couple of other things he's done. So this is what made me fall in love with processing. When I realized it could do stuff like this, and it was just a single click, you could export it to the web. This is sort of a fractal-like thing. It's different every time, so sometimes you get really beautiful ones and sometimes you don't. So I also looked at a lot of other languages, and I'm not putting them down. But I had to pick one, and for the ease of programming and the quality of the visuals, I chose processing for that class. And it worked out very nicely. People really dug it. There's one more I want to show you, Bubble Chamber. This is just really a sweet applet. There are 4 kinds of particles, and they kind of, they're flying around inside a collider. Let's see, do I have to, yeah, there we go. So as you saw the Java thing come up. These are all, what happens, processing sits on top of Java. It looks like a subset of Java, and it sort of is, but there are differences too. So it is not strictly a subset of Java. There's a whole lot of overlap. But there's some processing commands that don't exist in Java. Some Java commands have been tweaked and changed in subtle ways. But it was designed to let you crank out this kind of stuff real fast. And I mean, notice that there are these nice embossing effects. I mean, it's really, really dirt simple. And the source code is there. And one of the ways I learned processing was looking at the source code for this thing. In fact, why don't we bring it up just so you can see what it looks like. Here are all these examples of pictures he's made. I mean, how can you not fall in love with this? Oh, okay, so we're not getting it right now. But the source code is out there. So I fell in love with this thing, and I thought, okay, this is great. When I'm off to give my class at SIGGRAPH, let's see, can I blow this up? No. So I thought when I'm off to give my class at SIGGRAPH, I'll talk about processing for 10 or 15 minutes. So I did that, and people loved it. And so the following year, I thought, well, I'll talk about processing again, but, you know, I need to write some lecture notes or something. And I went to the coffee shop, and I opened up the laptop, and I figured, okay, I'll bang out 3 or 5 pages of lecture notes. And about 5 weeks later, I had a 1,000-page book. Because it just happens that way sometimes. So, okay, I had this book on processing. The book, I chose to do it in a weird way, and in fact, there's a lot of overlap with what Michael and Stephen did. The book is not like a regular programming book, and I've got nothing against regular programming books. I've read a million. We all have. They're great. But this was meant to be for artists. The idea was this is people like this guy who are making art installations. I don't think that this guy cares much about programming at all. He wants to make pictures like this. And you know what? Getting out a paintbrush and getting out, your paints and doing that, that's one way to go. But if you want to make 100 of them and with variations, computer's the way to go. And so you got to learn that tool. Well, that was the idea of the book, was let's help people learn that tool. the primary thought behind the book was programming is not interesting in and of itself. I'm not coming to you because you want to learn to program. You don't care about it. You want to make art. And I happen to have a tool that does it. So I'm going to teach you the tool, but the whole reason is so that you can make art. And you know what? If processing was a system for teaching otters to roll around in paint and then roll around on a canvas, and that made the pictures that we could make here, I would have taught you how to train otters. It's not the programming, it's where it gets you. So that was the first thought. And I thought, okay, how can I do that? And I went through the same sort of thought process that these guys did. I said, all right, what most programming books do is not universally, but often, they're depth first. You know, here's the structure of the if statement. Here's the syntax. Here's the Boolean. Here are the Boolean types. You know, here's how to evaluate a Boolean. Here's what happens if you do an assignment within a Boolean. You know, and you get into all this detail. Furthermore, a lot of programming books, because they expect some sophistication from you, will present you with syntactical stuff and grammatical stuff, knowing that you know why it's there. And I figured people new to programming, they don't know why, and furthermore, they don't care. So my thought was, I'm going to, very much like what they did, only without prior collusion. I said, you know what, I'm going to sort of set up these little projects that we want to do. And I'm going to say, how can we possibly do this? Oh my gosh, we need something that can like make a choice. By golly, it exists. It's called an if statement. It looks like this, let's use it. And I didn't get into the detail. And the idea of the book was, each time we talk about something, we just glance off of it. We just sort of touch it and move away. We learn just what we need to know. And later, when we need to know more, we'll come back to it. And then we'll come back to it again, and we'll come back to it again. And by kissing it many times throughout the course of the book, we will come to know this thing in its entirety. That has a number of benefits. One is you don't get slogged down with tons of detail. Second is you get to integrate the information as you go. Third is accumulated mastery, right? It's not like, oh my gosh, we're going to spend 3 days learning about if statements, but we've never even heard of a while loop. No, we'll spend 5 minutes on if and 5 minutes on variables and 5 minutes on whiles, and we can do stuff. The second approach that I took with the book was leave in the bugs. I wrote dozens and dozens of programs for this book, and I took a snapshot every time I added anything significant. 5 lines, changed the data structure. I was sitting there in the coffee shop. I didn't even realize I was going to use it. I just thought I was making a trail of breadcrumbs for myself. And so I would, make a little change, run it. Oh, bug. Oh, I left a typo. Snapshot the code, stick it aside, fix the bug, run it, got it, grab a snapshot. And so I had dozens of snapshots for every program. And they're all in the book. Because that's how you program. None of the programming books do that, right? They say, here's how to make a bank transaction system. And they break it down into the modules, and they show you the modules, and then you have 20-page of code listings, and you're done. And nobody writes code that way. You write 5 lines, you run them, they break, you fix them, you run them, it works, you save it. So I thought, this is what real programming is. Why pretend it's anything else? And so in the book, there are figures. Every time I develop a program, and I'll show you a couple of these programs. In fact, let's go to one right now. Okay, so let's switch to the other computer, please. Thank you. And it looks like so here's a little processing program. We didn't talk about type, and I thought I would just open with a little typography. Processing can do type. So I'll show you a couple of the programs that I wrote for the book, and then I'll talk about how they got developed. So let's go to group 1. So one of the things I did a few times in the book is I made postcards from other planets. So every time you run this applet, you get a different postcard. So let's run it a couple of times. And they're all sort of the same. They're all winter scenes on a world with sort of puffball trees. But there are many, many layers, and there's all kinds of stuff happening here, right? The snow is reflecting the sun. The sun is coming through the trees. There's illumination on the trees. There's color stuff going on. There's actually a whole lot of stuff going on. Well, in the book, there are probably, I'm guessing, 60 versions of this program. And they're all online. I mean, I don't list them all, obviously. But they're all up there on the website. from the very beginning, from the first call that just says, make a screen 600 by 600, to the next line, to 3 more lines, to 5 more lines, including all the broken ones. And so every processing generated figure in the book, and there are like 800 of them, every single one in the caption contains the URL of the code that made that picture, even the ones that are horrible and broken. Even the ones that comes out and it's like, oh my gosh, my picture went black. Save the URL. You can run that code, regenerate the black picture for yourself. And you can fix it yourself if you want, or you can see how I fixed it. So I thought this was an important learning tool. The book is the annotation in some sense. I deliberately, and I talked about this quite a lot in the book, and it was a real do as I say, not as I do. The code is largely uncommented. And it just has to be that way, or it just gets overwhelming in a book to have all those listings. They double in size with comments.
What I meant was okay, screen went black here. Did you put screen went black associated with that snapshot?
When it wasn't obvious what was going wrong. But yes, in the discussion, if you're reading along in the book, I'll say, okay, and now we'll set v equals 3. Let's try it out. Well, that's wrong. What went wrong? Well, we have a loop and blah, blah, blah. And I talk about my thought process in trying to fix it. And in fact, as happens, sometimes I couldn't find the bug right away. I went after the wrong things. Sometimes, in fact, in one place, I couldn't find the bug. And so I built this whole extra bunch of code to demonstrate things, to show me what was going wrong somewhere else. That code had a bug in it. Well, it's all there in the book because that's what it's really like to program. I was trying to demystify the process. So yes, if you're reading along, you're probably thinking, this guy doesn't know how to program worth beans because nobody else has these problems. But I figured put it all out there because that's real life. Let me just show you a couple of quick other little programs so you get a feeling for the sorts of things we do in the book. So that was actually one of the more complicated ones. Let me show you another of the complex ones, and I'll show you a few of the simple ones. One of the beautiful things about programming in processing is you can do really complicated things with really small programs because it's got all the right geometric primitives built in. And so these are little grains of sand, and they're falling down, and they're being blown around by fans. And if we let this run over time, we get some very beautiful snapshots. Let me show you 2 others. Group 1 spin cubes. I wanted to show you that processing can also do 3D. It's not a real big 3D program. That's not its real strength. Its strength is 2D. But this is 3D, and it's running. And it's all native to processing. It's all built in. It's actually talking to OpenGL, but you don't have to learn any OpenGL. And as most of you have probably guessed, what I have here is a grid of cubes, and I have a different picture pasted on each side of the cubes. And I have several different patterns for turning the cubes over time to reveal a picture. And in fact, one thing I'm doing, I have many more than 6 pictures. And so after each transition, I change the picture that's on the back face. So we mix up the photos. So there's 3D. Let me show you a really simple example of something in 2D. Really short bit of code. Group 2, set 1. Wheels. Okay, so here's the whole program I'm about to show you. That's the whole program I'm about to run. This took 1 commercial break during the Colbert Report. One night, I'm watching Colbert, I had an idea. By the time the commercial break was done, the program was finished. And it does this. And I don't know about you, but I love this stuff. I mean, I could watch this for a really long time and fiddle with the numbers and change the number of rings and change how they spin and change, the phase relationships between the rings. And you can just play with this thing for a very long time. And this is the kind of thing that prompted me to think, yeah, this is worth talking about, this is worth teaching. And again, I'm going to stop that. There's the whole code. And it's all the stuff that you guys just saw. In fact, we can walk through it real quickly. I set up a bunch of floats, a couple of colors. They're set up, which we saw before, right? I create a window, 400 by 400, and turn on anti-aliasing. Here's the code that gets evaluated every frame. Clear the background, set up a couple of variables, run through a loop. I fill in. I set a fill color. I draw an ellipse. I set another fill color. So basically, what I'm doing is I draw, say, an orange circle, and I cut it in half, and I draw a blue semicircle. And then I get smaller and rotate. Draw an orange circle and a blue semicircle. Get smaller, rotate. That's it. And that's all that's happening here. The radius is getting smaller, turning. Do that. Change the starting angle and delta on each frame. That's the whole program. Cool. Now, could you do this with all sorts of other programs? Absolutely. I mean, there are lots of programming languages out there that can do this. For me, the beauty of processing is it's just that easy, you just knock it out. Although, as Michael and Stephen said, the IDE is beyond awful. There's nothing to it. It's bare bones. If this doesn't run, you start putting in print statements, which is ridiculous. Now, there are external IDEs that you can use for processing, but the native has like no debugging abilities. So I want to wrap up. So I was talking to a couple of people about this book, and they were my target audience, designers, who wanted to learn how to do this kind of thing for their art, to make museum kiosks, to make interactive installations. If you go to almost any museum, you will see tons of processing stuff all over, because it is the mechanism of choice for visual artists who want to do the work themselves. They don't want to learn Flash. They don't want to learn After Effects. This gives them the tool. So I was speaking to somebody who wanted to do this, and I said, "Oh, it's great! Perfect timing. I just wrote a book." And her reaction was, "Well, yeah, but where can I find the videos?" I said, "Well, no, I haven't done any videos. I wrote this book." "Yeah, but there's a website like YouTube, right, where you have the videos in the book." Well, this conversation went on for a while, and I realized my target audience doesn't read books. I just wrote this 1,000-page book, and it's beautiful, and I fell in love with it when I saw it. And they want the YouTube URL. Well, this happened a few times. So I decided, okay, I'll teach online. So I'm now taking the material from that book and a lot of additional material, and I'm using it to teach an online course, which I'm now putting together. I'm putting together a huge website. The course is going to have just dozens and dozens of little videos. And each week, I give you a little path, like jumping from one lily pad to the next, through a part of the world. And so, if you want to learn more about recursive programs, there's a lily pad for that, but I don't talk about it because it's not on the main path. But it's there if you want it. And so every week, I'll assign homework. People will do their homework, and I'll give them back feedback. I'll record a new video that talks about what they've done in their homework, and I talk about everything from the code formatting to the color choices, to the aesthetics of the piece, to how things move, to the actual implementation, and then I riff on it. And I say, okay, given the code that you wrote, here's another place we can take it. I actually have done a test run of this course live with a couple of people over the course of several weeks, and learned a couple of interesting things. One was they loved the feedback, and I was a little concerned that people would say, you're going to take my program, you're going to take my work and change it and extend it. And in fact, they love that. They send you a thing with 4 balls that are coming together. I actually have that, but I'll skip it for now. But I can show it to you if anyone wants to see it. And I say, okay, well, you could take that and enhance it. You have many balls coming in, sliding, and rotating around as they move. And they love that. They say, that's where I can go next time. Second thing is they really like this business of being able to revisit a node. Being able to say, oh, wait, there's this one little thing I don't get. I can always go back and check it again. So that's the nice thing about having little videos. The third thing is they won't read the book. The first thing we did when we sat down to give this course is I sold them each a copy of the book, and they were happy to have it. In the middle, it became clear to me they would not open it. They would write to me, and they'd say, I don't understand how thus and such works. And I would write back, and I'd say, well, no worries. From page 315 to 318, I talk about exactly that. There's a discussion, there's figures, there's example code. I sweated bullets on it. check out page 315. And they'd write back, obviously having not taken a look, say, yeah, but I don't see how the da-da-da-da-da-da-da. And we'd go back 2 or 3 times, and finally when I realized they will not open the book, basically I would transcribe what was in the book. This is part of my learning process. And I didn't do it verbatim, because I didn't have, figure 18.3. I would just say, see the screenshot, right? And I would basically, with a little bit of change, type in what was in the book. Pages of email. That they would read. That was fine. And they were grateful for it. Oh, thank you. That explains everything. So for me, the lesson is you got to do it in video because that's what they want. And you have to give your audience the information they want the way they want it. So I have a bunch of books if anyone wants to see them. And we can talk about this course, which I hope will be live in a few months.
Read the book. It really is a great book. Anyway, so Andrew's got some books if you're interested. Said if any of you are interested in doing anything remotely like this, you know where to find us. And happy to just give you all the code. Obviously, there's way more code than we can give you out there on the web and other projects. And we actually got a lot of inspiration just going through the index in Andrew's book. We got a very early copy before we did the course and drew some of the ideas out of there. So I can attest to that.
Quick question.
Yeah.
The girls were what, about 13 years old or so?
Yeah.
How young do you think you could have gone and been successful?
Very good question.
Yeah. This was actually in our thinking a lot as we were designing some of the projects because some of them might involve some math or trig or, we can't do that. And so I think we ended up, some of the things we could have done maybe a couple years earlier.
Yeah.
I know that we've done stuff individually with our daughters quite a bit earlier, when they were 8.
Yeah, I would say a couple of years earlier would have been fine. Now we don't really know what 15-year-old girls are like, but I'm going to guess that might be too late, judging from what 13 and a half going on 14 is getting to be like.
Well, you have to remember they're your own daughters too.
Yes.
I had a question about why, you did the robotics thing with boys and girls, and then you decided to do the art. What was your learning from the robotics that made you decide on art?
There were a couple things. One of which was that a lot of times they wanted to do stuff, but it was too hard to express in the robotics. I remember, let's make it juggle. It was one of the first things that they wanted to do. And they actually wanted to do something a little bit more expressive than was possible in the confines of the robot. And that was, again, why we chose some of the paint stuff. And that's also why we didn't choose this sort of programming with Alice. Because Alice is great for doing certain things, but you were a little bit constrained to this 3D environment that you did, or you did 3D modeling rather than.
Because are you aware there's a huge debate in sort of the K-12 community about the entry paths, robotics versus Odoo versus Scratch, etc. And I love your immersive approach, and your book is all about tinkering. My hypothesis is that tinkering and immersion and fun are the way to attract kids. And 15's too late, you know it in your gut.
Yeah. And
it might be too early, but encouraging tinkering and fun.
Yeah, I've grown up over 25 years of, computer graphics, starting from when nobody had ever even seen a picture on a screen to when we first saw an actual picture come up on a screen, a digital image come up on a screen, and then getting into 3D and 3D lighting and 3D animation. And for the last 15 years, I've been going, no more 3D, I'm going to go back to 2D. No more of that, I'm going to start from photos, which is why I'm kind of envisioned. And you realize after going down that path, 2D is wonderful. I mean, it's just, paints on a canvas is a great thing. And just start there. So yeah.
And we do know some friends that have gotten in via the robotics route. Like David Heckerman, his son is really into to doing that, and he loves that. But it never clicked with you.
Partly also we were doing this online kind of course that was trying to be developed from people at MIT, right? So we actually had them on video, and so we had a lot of technical things. And the particular project in this class was to create this little garden And so they had all these pipe cleaners, and they were making little things out of it. And, again, you sort of saw the girls just totally spend all their time building these little flowers and things out of pipe cleaners and little plastic bits.
Right.
And, the guys were like making little catapults. And it was okay.
And it was also kind of removed from the programming stuff. Because it was sort of like, oh, well, I go up and open this up and it does this, and okay, I'm done. And they didn't really embellish in that direction. They embellished in the pipe cleaner direction.
Yep.
Another question. I read the original book on processing long ago, and I thought, what a beautiful thing. It's a shame it's got to carry the weight of Java along with it. I would imagine it's 10 times as bad for 13-year-olds. That you've got the semicolon fetish to deal with. What would have made this better from a purely programming language point of view? Not necessarily the processing primitives and model, but just.
Yeah, somebody should write a nice IDE, nice development environment around it.
So you don't think Java would have been a problem if there had been a nice IDE?
Yeah. In fact, we looked at the small basic and had, when she showed it, and that's very nice because it does IntelliSense, it does semicolon and indenting and all the other things that just makes it such that you can't make as much of a mistake. It tells you what the mistake is. Here,
it gives you choices. Do you want, this is it, and you pick one, or,
Yeah. Although that might have, I'm not sure how flexible it would be to. I think it would at least help with all the syntactical errors.
Yeah.
To get in that way.
Yeah.
So.
It's a fine line, right? If you get more and more and more help with auto, syntax fill-in, then your flexibility starts feeling a little constrained because you start to go outside of that. It doesn't seem to know how to help you anymore. But yeah, some of that would have gone a long way.
I mean, it seems ridiculous to me to teach a 13-year-old to declare a variable.
Yes.
We were kind of worried about that, but it seemed to not bother them. So you did it this way. They were learning all. You said fine. I mean, the hardest thing was the sort of scoping of the parentheses or of the brackets.
Yeah, I need another variable, so you just copied it some other variable. It's really just by example.
Yeah, and maybe it would have been better to take something that was just like Python or something where you wouldn't have those types.
Yeah, we talked a lot about.
Yes, show. In fact, we even considered that because Python is really a fun language to do.
Right.
But it didn't have the other thing about processing that we didn't really talk about besides the artistic community. There's tons and tons of libraries out there for doing all sorts of other things. We're doing 3D. We're doing Arduino, and I know Asta is really into trying to do some sewing and stitching, and she really wants to learn processing because she wants to be able to program those little things in it, because that's what the community does.
Yeah, so we've been actually talking to Asta, and we have another, there's a student we co-advised from UW, Mira, who's now down at Adobe in San Francisco, has been getting into these Arduino little boards and fashion. So I've been contemplating trying to do a fashion with little Arduino, blinky lights, dresses and shirts with blinky lights thing maybe this next summer as a kind of the next thing to do. Yeah.
I was just curious why I thought 15 was too late for them.
We don't know. We have 13-year-olds.
It was,
so.
There's this point where.
But you can you just kind of take the vector.
Yeah.
there was this. You're going to claim a whole week of my summer, and force me to do this stuff.
Yeah. Anyway, all right. Anyway, follow up with this as much as you like. If you're interested in the book, there's some. Talk to Andrew.